Hello everyone, I'm from Huawei OceanStor Mass Data Storage domain, and today I will introduce a feature designed for OceanStor Pacific series, multi-protocol interworking. First, let's look at its background. As cloud, AI, and big data technologies are becoming mature, traditional data processing is changing. Now, a data processing operation may involve data in multiple formats, such as file, object, and HDFS. Take autonomous driving as an example. The raw data returned by a drive test is in file format and needs to be converted into the HDFS format before being processed by a big data system. So, the processing result is converted into the file format and imported to an AI training cluster and a simulation cluster for verification. Finally, the file data is converted into the HDFS format and imported to a big data cluster for analysis, with the analysis result used to adjust the autonomous driving algorithm. This is also the case for oil and gas exploration, where raw seismic data is generated using artificial seismic waves. After seismic data processing and interpretation, and oil reservoir simulation, the reservoir location and oil reserves are preliminarily determined, and then a big data system is used for data mining. During the data processing, data is converted between file and HDFS formats multiple times. Currently, each training vehicle for autonomous driving generates up to 64 terabytes of data every day, and the amount of 3D seismic data collected per time reaches petabytes. The time needed for data migration and conversion accounts for over 35% of the total data processing time. To improve the efficiency of processing diversified data in various industries, storage vendors are trying a new technology, multi-protocol interworking. How is multi-protocol interworking different from pool sharing? Pool sharing indicates that a hardware resource pool is shared. Generally, multiple independent logical resource pools are created for a set of hardware, and file systems, object buckets, and HDFS namespaces are deployed. Each logical resource pool can be accessed using only one protocol. If cross-protocol access is required, data is copied first and then its format is converted. Pool sharing can improve hardware resource utilization, but is insufficient to process diversified data. Multi-protocol interworking not only implements a hardware resource pool shared by multiple protocols, but also enables a logical resource pool to be accessed using different protocols, such as file, object, and HDFS protocols. A piece of data generated by one protocol can be directly accessed by other protocols without converting its format. Multi-protocol interworking simplifies data management. By implementing a unified storage resource pool and hardware resource sharing, logically, only one unified file system is required, simplifying storage planning, configuration, and O&M. Also, it accelerates data flow. Different data processing engines have different requirements on data formats. With multi-protocol interworking, data can be analyzed and processed without being copied. A typical data processing operation can be reduced from 6 steps to 4 steps, improving the data analysis efficiency by over 30%. Another key feature is that it saves storage resources. Shared hardware resource pools improve storage resource utilization. In addition, no redundant data copy is generated, saving storage resources in end-to-end data processing. Let's look at how multi-protocol interworking is implemented. As we know, it is typically implemented using protocol gateways. For example, an object protocol is converted into another format using a protocol gateway. In this way, the storage architecture does not need to be reconstructed, and the major development workload lies in the protocol gateway. However, this implementation method has the following restrictions. The first is poor usability. File or object gateways and HDFS plugins must be deployed, and applications on the compute side must be reconstructed. Another drawback is semantics loss. Limited by the technical architecture, some semantics, such as CIFS, are not supported. In addition, some semantics, such as appending and renaming, are inefficient, and the service logics of the application layer must be modified. This method also causes performance loss, which is a result of protocol conversion required by data access. The performance following object to HDFS conversion is less than half that of native HDFS. The final drawback is the lack of value-added features, as it is difficult for a value-added feature constructed based on one protocol to be shared by other protocols. To achieve real interworking, Huawei OceanStor Pacific series, with its original architecture reconstructed, uses data and metadata of the same model, unified value-added features, and the abstract semantic layer to form a unified unstructured data management system. The multi-protocol interworking feature of OceanStor Pacific series is easy to use, requiring no gateway, and is easy to maintain. It also offers lossless semantics, providing native semantics for file, object, and HDFS protocols, all without syntax loss or limitation. Likewise, there is also no impact on performance, providing the same data access path as a single protocol. Most importantly, it allows diversified value-added features to be shared by all protocols. When it comes to the technical challenges of multi-protocol interworking, we must consider metadata. As we know, object metadata adopts a flat structure and consists of buckets and objects. Because objects in a bucket are discrete and have no relationship with each other, object storage offers excellent scalability. A single bucket contains up to hundreds of billions of objects. In addition, object metadata is sequential. After running the list object command, we can gain a sequential result. Object storage supports value-added features such as versioning and multi-part upload, which are related to metadata. However, file metadata adopts a tree structure and consists of directories and files that are mapped to each other. The tree structure is suitable for human-computer interaction and also enables file systems to provide high performance and low latency. However, file systems do not support sequential metadata, versioning, or multi-part upload. Based on the characteristics of file, object, and HDFS metadata, OceanStor Pacific series adopts a unified architecture. It uses the inner directory fragmentation technology to support hundreds of billions of files in a single directory and ensure high performance and low latency for data access in each directory. In addition, it uses the inner file fragmentation technology to support object versioning and multi-part upload. Also, metadata is stored in sequence, and native object interfaces such as list object, lifecycle, and bucket policy are supported. Multi-protocol interworking of OceanStor Pacific series allows a piece of data to be read and written using multiple protocols at the same time. In the I/O process of concurrent access, the lock design is the key. Lock mechanisms vary between protocols. NFS and CIFS support file locks such as open and lease, as well as more fine-grained range locks. However, HDFS supports only file locks, and S3 does not support any locks. OceanStor Pacific series provides unified lock management and supports the lock mechanisms of all protocols. This unified management allows clients using different protocols to apply for locks before writing data. Only clients with locks successfully applied for can write data, ensuring data consistency. In addition to the unified metadata architecture and lock design, OceanStor Pacific series also provides unified value-added features. The first is unified QoS. OceanStor Pacific series uses a QoS server. An independent QoS agent is deployed for each protocol and applies for tokens from the QoS server to implement multi-protocol comprehensive traffic control. The second is unified snapshots. Snapshots are created for all data in the same namespace at the same time. Because object storage does not support snapshots, we provide a unified snapshot design to break this restriction. Also, OceanStor Pacific series offers unified retrieval of unstructured data. All protocol metadata is synchronized to the unified metadata retrieval engine, and target data is retrieved from all protocols. In addition, OceanStor Pacific series supports value-added features such as unified storage tiering, remote replication, and multi-tenant. Going forward, we are confident our multi-protocol interworking feature will break the barriers in diversified data. Thanks to its simplified data management and data processing, OceanStor Pacific series will help you cope with mass data to stay ahead of the technology curve. That's all for today. Thank you for watching and see you next time.